Hello everyone, my name is Manuel Silva. I am a PhD student in the Universidade Católica Portuguesa School of Arts, and today I'm going to present our research, Extended Reality Experience in Museums for Cultural Heritage, a systematic review. This research is divided in 6 parts. Introduction, where we introduce the research context and objectives. Reality-Virtuality Continuum, which demonstrates the augmented reality, mixed reality, and virtual reality terms, and introduce the new term extended reality. Then, we present the research methodology used and the results that were obtained. After, in case studies of XR experience in museums, we present the case studies that use XR technologies in museums for cultural heritage content. Then, we analyze the tables obtained from these case studies, and to sum it up, we finish with the results, discussion, and future directions. This research is a part of an ongoing research that is linked to my PhD project, which is the interaction with immersive environments using XR technologies to represent multiple perspectives of cultural heritage, the case study of Contemporary Art's Robes Museum. For this, we needed a state-of-the-art into the use of extended reality technologies in museums for cultural heritage. In order to do so, we follow the guidelines for conducting a systematic reviews of research based on Okoli and Schwabram, and analyzed XR case studies that contain experience in terms of objectives, results, locations, software, hardware, and evaluation, with the aim to answer the following research questions. Question 1. What is the total distribution and volume by geographic source, location, and time of issued studies on XR technologies and museums experience? Question 2. What authors, journals, and research articles have had the highest impact on studies focusing on XR technologies and museum experience? And third, what type of experience are being developed with XR technologies in museum experience? Then, in virtual reality continuum, we introduce some key concepts such as augmented reality, where the reality is enhanced by adding extra digital content over the real world, mixed reality, where the real world and the virtual world blend together, combining interactivity and immersion, offering immersive interactive experience to view the real virtual world, thus uniting different properties of the continuum into a single immersive reality experience. Virtual reality, which creates a whole virtual world around the user that uses a headset to enter these virtual worlds, being fully immersed in a computer simulated reality. And finally, the extended reality, which is the umbrella that encompasses all these terms. And according to Fast-Verlang, extended reality defines a spectrum of new media technologies such as augmented reality, virtual reality, and mixed reality, as well as all future realities such technology might bring. For our research, we followed Okoli and Schwabram's systematic review methodology, beginning with a setting of review protocol, a systematic search process, practical screening, literature research, and data synthesis. We performed a systematic literature search for articles published from January 2000 and August 2021, based on Scopus and Web of Science, digital libraries. We include articles written in English related to extended reality and museums and cultural heritage with transparent methodology and from trusted resources and journals. We exclude those that are not submitted to peer review process or whose studies full text is not available. The search strategy was designed to retrieve publications that were evaluated for eligibility and inclusion. The quality of the search strategy is vital as it affects what items may have been missed. The chosen keywords and the relationship between these keywords were the same for searches in each database. By utilizing the search string, we retrieve 14 results from Scopus and 24 from Web of Science. After applying our selection criteria presented in Table 1 and checking for cross results, we end up with 27 results. By applying a manual check of the content of the full articles, 2 articles were excluded since the authors never related to or approached extended reality or extended reality technologies in their articles, being left with 25 results. From the total of 25 publications, 13 publications were in journals and 12 in conference proceedings. Analyzing articles publication, 6 articles in the first 6 years, and since 2019, 8 articles. As for conference publications, 2018 was an exceptional year with 5 conference publications. This is the same as the number in the period before 2018. After 2018, 4 conference publications are already present. The Table 2 presents the contribution of each country to the extended reality in museums for cultural heritage area. Of the total of 12 countries, Greece and Italy are on the top of the list with 20% each, followed by England and Romania with 12%, which make them the top contributors with 64% of the total publications. Then we have Portugal, which contributes with 8%, and the rest of the countries all contributed with 4% each. This allows observing which countries are investing the most in the implementation of extended reality technologies in museums for cultural heritage. It was also possible to extract the top 5 authors on the field by citation numbers, which are demonstrated in the Table 3. The citations to the articles begin in the year 2015, not existing previous citations, which permits to observe the average citation number per year from 2015 to 2021, with a maximum average of 2.29 citations per year from the medicine and medicine authors. For publication areas present in the table, show that authors are publishing their work in different areas such as applied conservation science, arts, technologies, and engineering. We also explore the distribution of articles per journal, where the MDPI journal has the highest impact of publication with 31% of the publications from the 13 articles. This is a journal that has a mission to foster open scientific exchange in all forms across all disciplines. For the analysis of our case studies, we had the keyword to our previous string, experience, which left us with 17 results in total from both databases. Since there is no time to show all the case studies, we are going to present some examples. The first example comes from Medicine and Medicine, where the authors present in 2015 an augmented reality system with the objective to facilitate the preservation of information to visitors. This system is divided into 2 parts. The first installation uses a tablet connected to a large TV screen that allows a single visitor to operate the installation, while the other visitors can experience the visualization as over-the-shoulder specters. The second installation is a handheld experience that allows multiple visitors to operate their viewfinder, enabling them to use it as a window to the past and create their own tour throughout the chapel. The second example, from Galdieri and Carrozino in 2017, they developed the Muse tools with the objective to create a system that allows museum curators to be independent while creating reliable virtual space, reducing the gap between curators and technology. The system is based on an extension of the Unity 3D game engine software to support new features and tools to allow the curator to plan real and virtual exhibitions without relying on expert programmers or artists. A full explorable virtual museum with 4 rooms plus an external open space to demonstrate the possibility of abstract virtual reality in combination with human heritage exhibition was created using only the features of the author system, showing its capabilities to create a virtual and concluding that it is unlikely for this demo to be recreated by a single museum curator. The third example, in 2019, Benfi et al. Present a holistic approach to the Basilica of Sant Ambrogio in Milan that starts from data collection such as 3D survey and historical records, followed by the creation of 3D models and ending with an extended reality experience. This experience offers an increased level of information and create an increased awareness of the intangible value and history richness that would be possible by the traditional ways. With their research, they discussed the potential and the challenge to the utilization of these technologies in cultural heritage field. One of the potential uses is they already consider increased availability of information to the visitors, providing multiple outcomes with different levels of information. But at the same time, these outcomes create challenges themselves, like the problems faced for the parameterization of historical buildings shapes, difficult to represent historical hypotheses, and the communication of intangible values. And for this, the authors propose that the creation process must be carried with communication between the creators experts, restorers, and historians. For our fourth example, Tenet et al. In 2020 show Thresholds, a virtual reality experience that recreates the world's first photography exhibition and toured multiple museums. The experience allows having multiple visitors at the same time in a real world and virtual space being replaced by ghostly avatars into the virtual world. The visitors can walk and explore the virtual world and experience the digital content, such as high-quality scans from the original photographs. Visitors were observed how they experienced the work to extract information for the design of virtual reality user experience for museums. For a final example, in 2021, Harun and Mahazir developed a 360 virtual tour of the traditional Malay house after having performed a literature review on virtual reality photography and analyzing examples of other 360-degree systems that already exist, mainly in the Asia area. They aim to preserve the architectural heritage for the future generation by providing local and digital visitors heritage information with effectiveness, simplicity, and a low-cost system. The system works with a simple but effective interface and delivers detailed information of the building displayed around the 360 world as an anchor point. Results show that the development of the virtual tour can indirectly attract the people's interest in the uniqueness of traditional Malay houses. For the XR studies table analysis, in this chapter, to answer the first and second question, we organize the information into two tables. The first table, table 4, displays the case studies in terms of locations, objectives, evaluations, and results. For this analysis, two case studies are not included because of being conceptual articles and not having an implementation of an experience, thus being not present most of the information required to the table. In table 4, location is referred to the place where the experience was tested, for example, a museum, university lab, or other, standing for a city, space conference, and etc. The objective is the main goal of the experience, and the evaluation reports if any type of assessment was performed and if it occurs, how it was evaluated. For results, we consider three possibilities: the R1 for a prototype, the R2 for a pilot, and the R3 for a product. For table 4, we can observe that near 47% of the experience was tested or presented in university lab, then 40% were tested in museums, in which half of the 40% were tested simultaneously in museums and others, and the other half was in museums only. As for other location, only 13% was, since some of the experience were tested in both museums and other, or university lab and other, in total of 33%. In terms of evaluation, 53% of the experience were evaluated using mostly qualitative methods, typically questionnaires with a number of participants ranging from 12 to over 250 answers. 47% did not report any kind of evaluation of the experience. Regarding the results, 40% are prototypes, 33% are pilots, and 27% are already products. Table 5 presents information regarding technology used to implement the experience for extended reality modality, software platforms, and hardware devices. According to Table 5, 53.3% of the experience used only virtual reality. Augmented reality was used in 33.3%, and 30.3% use mixed reality or extended reality. Analyzing the software and hardware components, 2 publications do not mention which software is used, and 2 publications do not mention which hardware is used. Regarding the 13 publications that have referred software or hardware, 54% used Unity 3D game engine and 23% used Unreal game engine. As software platforms, 31% use mobile devices only, such as cell phones or tablets, while the remaining 69% use a desktop mixing with the other types of hardware, such as head-mounted display, a large TV, screens, leap motion sensors, and mobile devices. With this, we can observe that 77% of the authors are utilizing game engines to develop their experiences and utilizing more common approaches in terms of hardware with mobile devices and desktops, indicating a path to the standardization in software and hardware for the creation of extended reality experiences. In this paper, we explore and analyze a literature review of research made in Scopus and Web of Science digital libraries. The relatively small number of publications indicates that the use of extended reality technology is still in its early phases in cultural heritage area in museums. With these results, we answered our 3 research questions for the extended reality in museums experience. The first question: where is the total distribution and volume by geographic source, location, and time of the issue studies on extended reality technology in museums? Showed us that after the year of 2080, we start to see a growing number of publications, and the countries Greece and Italy are the ones contributing the most for these publications. The second question: what authors, journals, and research articles have the highest impact on studies focusing on extended reality technologies in museum experience? Present us that the authors Anatozavis, Banfi, Katial, Madsen and Madsen, Spiridon, and Sendo are the top 5 authors with more impact in studies of extended reality technologies in museums, and as for the journals, demonstrate that MDPI has more impact with 31% publications from the 13 results. The last question: what type of experience are being developed with extended reality in museum experience? Presented that the majority of the authors are developing virtual reality experience, resorting to game engine software to develop their experience. From our findings, it is present that the extended reality will be adopted by even more institutions since it has clear benefits for attracting visitors and encouraging revisits. Extended reality technologies can help to preserve and reviving cultural heritage, lost content. And also, extended reality technologies have a positive influence on the cultural heritage, giving several different tools to this area to develop better and enhanced experience for the visitors. As for future works, there is an option to do a literature review of extended reality with augmented, virtual, and mixed reality terms to see how much influence the number of results, and also to explore the geographic distribution to find if exists the difference between the selection of extended reality technologies when developing experience in different countries. The design of experience and evaluation process can also be thoroughly explored and compared between articles to understand the existing difficulties when creating extended reality experience for cultural heritage in museums. Thank you very much for your attention, and feel free to read the full paper where everything is further explored.